Before you get started on this section on hyperbolic functions, I want to look at a very common construct where you can take any function that might have like whatever kind of asymmetry in it, and you can make an even function out of that. And so here is some just kind of wild looking function that has no symmetry to it. And there is a kind of canonical way to make an even function out of that. And this is what that canonical even function looks like that is based off of this original function. And you can kind of see that it's related there. And then there is a canonical, similar canonical way to make an odd function. And you can kind of see that it might be related. It's a little bit surprising how tame this odd function is compared to the original, but that's what it is. So I want you to take a look. So here is the definition of one of the sort of standard ways to create an even function given any other function. And if you think about like why this function is even, we can do a calculation, and so we can see that if I calculate g of negative x, that's going to be f of negative x plus f of negative x, which is then f of negative x plus f of x. And since addition is commutative, I can swap the order of these terms and see that's the same as f of x plus f of negative x, which is, of course, g of x. And so this shows that g satisfies the condition of being even. And notice that we're not using anything particular about what the function f is. Like, we don't even know how f is defined. This is true for any given function f, as long as it is actually defined on both sides of 0. Okay? You might pause the video for a minute and see if you can figure out how to make an odd function out of f. And I will reveal that now. To make an odd function out of f, it's basically the same construct, except we use a minus here. H of x is f of x minus f of negative x. And if you kind of think about why this is odd, if we substitute in the opposite of x, that will be f of minus x minus f of minus x, which is the same as f of minus x minus f of x. And now this is not the same thing as f of x minus f of negative x, which is h, but this is the opposite of h. This is negative h of x. And so this shows that h satisfies the condition of being odd. And again, this doesn't use any properties of f, like we don't even know what the definition is of f in this particular case. Now, in section 3.11, this is defining hyperbolic functions. And so for that, it's basically doing this construct, but with the exponential function. So here, like in this case, I made this kind of crazy function. And if I change it to just e to the x, then this is a highly not symmetric function. And we don't, so I said that this is the canonical way of making an even function. It's not quite. Generally, we actually take 1/2 of this sum and 1/2 of this difference as my canonical even construction and odd construction. So when I do this with e to the x, the even constructed function is called the hyperbolic cosine function, and the odd construction is called the hyperbolic sine function. And another interesting thing about this is when you do this sort of canonical construction where we take g of x is 1/2 of f of x plus f of minus x, again, back to like given any function itself, and h of x is 1/2 of the difference of those two functions, then if you add the even function and the odd function, you will get f back. So add g of x plus h of x, and you're going to get 1/2 of f of x plus 1/2 of f of x, and then these two terms are going to cancel, and so it's just going to be f of x. And so some people think of this as really splitting f into an even part and an odd part. And so this is the even part of f, and this is the odd part of f. So I just wanted to let you know that this is a thing that you can do with any given function, even though in section 3.11 we're doing this specifically with the exponential function.